Hi guys, it's Stuart again here from SD Roberts Plastering and Wall Insulation, Coventry in Warwickshire. In this very brief video today, we're going to revisit this project from last week, the bay window project in Coventry. Those of you that have watched that video, you'll remember that we had a very cold curved bay window with sand and cement plaster on the inside, black spot mould and condensation problems forming on the curvature section, which was stripped down, insulated and plastered. Now I want to answer a couple of your questions that have come in. So a common question that comes in from you guys is, why not just use plasterboard when you're replastering these bay windows? Why do you use products like XPS, PIR or cork? Why not just use standard plasterboard? Now it's a great question, and to give you some insight into the answer, let's go back to the original material that was on this bay window, which was sand and cement. Now sand and cement plaster is very, very poor at insulating because it has a really poor R value, guys. Now the R value is the material's ability to resist heat flow. So you put the heating on in the room, and if the material's good at resisting heat flow, then it will have a high R value, so the heat will make contact with the material and the heat will move through that material very slowly. Now if that material has a low R value, it means that the heat's going to pass straight through that material through to the outside very quickly, and that's what was happening with the sand and cement. Now although plasterboard is 3.6 times better than sand and cement when it comes to R values, it's still relatively poor when compared to XPS insulation. So 12.5mm of XPS insulation, which is the product that I've used on this bay window, if we compare that to 12.5mm of standard plasterboard, for example, the XPS insulation is actually 8 times more thermally effective. In other words, it has 8 times the R value of a standard piece of plasterboard. Now it's important to mention as well, guys, plasterboard is porous. So if you install plasterboard onto a cold solid wall using dot and dab methods, for example, what can happen is warm humid air inside the room can bypass that plasterboard and the adhesive dabs, and it can make contact with that cold solid wall behind, and that's where interstitial condensation problems can occur. And in some cases, the plasterboard itself becomes mouldy and has damp patches because it's the wrong material to use on solid walls. So that's why we use impervious materials in these jobs, such as the XPS insulation. Now, if breathability is important for you and the property that you're working on must breathe, then there's many different IWI products that you could use that are going to work in unison with that breathable building. For example, cork, wood fibre insulation and things like the SWIP system. All these systems are great because they allow air to pass through the solid wall, unlike XPS, PIR and other modern insulation products. So let's revisit this job so I can show you the thermal uplift and the surface temperature of this bay window following the install of the XPS insulation. So we're going to take a reading of the internal walls again, just to refresh your memories. Now, when I took these readings, guys, it wasn't quite as cold as the previous day. So it's worth mentioning that the room temperature right now is around 18 degrees, and the internal walls are reading around 17 degrees, between 16 and 17 degrees. And if you have a look at the coldest point of the bay, well, it was the coldest point of the bay, we're now getting a reading of 17.8 degrees. Okay, and on this nib, it's now 16.7 degrees, and this wall 17.5. So the whole room is slightly warmer compared to the day before. You can see here the internal walls are now 17.3. We'll go back to the coldest point, 17.7 degrees. So essentially, by adding 12mm of XPS insulation onto this bay window, it's meant that the bay window is now warmer than the surrounding internal walls in the room. So that's always the target when we're installing IWIs. We're trying to get the cold, solid outside facing walls the same temperature as the internal walls. And you can see by evidence of this video, we've gone beyond that and increased the thermal resistance even higher. So I hope that explains why we always opt for XPS or PIR insulation on these type of projects. If you enjoyed this video, it's been helpful, don't forget to subscribe. We try to get these videos out each week, so next week we'll have another project to show you, giving you some more insights into internal wall insulation systems. Thanks for watching, we'll see you on the next video.